Hi everyone, today we're going to be doing some advanced problems when it comes to momentum and impulse, and also we'll be doing some center of mass problems. This is the last video for this. Alright, let's look at this. A 45 kilogram woman stands up in a 60 kilogram canoe 5 meters long. She walks from 1.1 meter from an end to a 0.1 meter from the other end. If you ignore air resistance to motion of the canoe in the water, how far does the canoe move during this process? Ignore air resistance. Okay, so just know that this canoe is going to be in the water like this. And what's going to happen is, as this person walks this way, the boat is going to move the other way. And another thing that we want to know when this person does walk from here to here, how much does this boat go backwards? That's what we want to know. One thing that we should know is, as this person walks to the right, and this boat moves to the left, the center of mass is always going to be the same. So that's something to keep in mind. So right now, making this the reference point all the way at the end, let's try to find what the center of mass is from the beginning before she starts moving. So we're going to do center of mass is equal, let's call this one M1. We'll call the boat M2. So M1 is 45 kilograms. She's located 1 meter from the 0 point. Then we have the boat, which is 60 kilograms. And since it's uniform, it's going to be right in the middle. And if this is a 5 meter long canoe, that means right in the middle is 2.5. And then this is going to be divided by the total mass, 45 plus 60. And then let's see what that gives us. 5 plus 60 times 2.5 divided by 105. Which gives us around 1.86 meters. Okay, so we know that the center of mass is around here, 1.86 meters. Now what we want to do is, we know as this person walks to the right, this boat is going to be moving to the left. So if this is a reference point here, the boat's going to be somewhat like this. Okay, it's going to be past the reference point. Okay, so we're going to call this x equals 0 right here. This person is going to be all the way on this side, and we want to know how much this boat moved backwards. Okay? So let's see if we can figure this out. We're going to again use the same formula. XCM is equal to M1 x1 plus M2 x2 divided by M1 plus M2. Okay, so we know the center of mass already. From this position, it should still be at 1.86 meters. Okay, so we don't know where that is, but it should still be at 1.86 meters to the right. That's 1.86. Mass 1 is still 45 kilograms. And what we know is she goes all the way to the right over here. So she's going to be at this 4 meter mark, but the boat has also gone backwards a little bit. So even though she's at this 4 meter mark, what we're going to do is we're going to write 4 meters minus m. Oh, not minus m, minus x. Because the boat has moved back x, so we're going to do 4 minus x. Now let's add this to the boat. The boat has also moved. The boat has a mass of 60 kilograms. And now the middle of the boat is going to be like, around here or something like that. And it has also moved. So we're going to say this is also 2.5 minus x. And we're going to divide this by all the mass again. 45 plus 60. So now let's do a little bit of algebra here. I'm just going to divide that 1.86 times 105. And then I get 195.3. And this will be equal to, I'm going to FOIL this out, 45 times 4. What's that going to be? 180 minus 45x, and then plus 60 times 2.5. And we get 150 minus 60x. And now let's clean this up a little bit more. 195.3 is equal to, and I'm going to add these two together, so that's going to be 330. Oh, and this should be 45x. Okay. And then this is going to be minus 105x. Bring this to the other side. 195.3 minus 330. 195.3 minus 330. and we get negative 134.7 is equal to negative 105x. And then we have x, how much the boat moves, going to be equal to 1.28 meters. Okay, so the boat moves backwards 1.28 meters. All right, let's look at the next one now. A 70-kilogram man is standing on the end of a 250-kilogram log that is floating in the water. Both the man and the log are at rest, and the log is 3 meters long. If the man walks to the other end of the log, how far would the log move in the water? Okay, so again, similar kind of problem here, but we want to just kind of get some practice with this because these are kind of difficult. So we're making this all the way to the left, the 0 point. Okay, and then let's kind of write everything out. Let's find the center of mass. So we know the mass of the person is 70 kilograms. He's all the way to the right, which is 3 meters. And then the log, which is 250 kilograms, is going to be pulled down from directly in the middle. So that's going to be 250, and then it's going to be 1.5. And then we're going to divide this by 70 plus 250. And let's see what this all equals. 70 times 3 plus 250 times 1.5 divided by 320, which gives us 1.83. Okay, meters. So that's where the center of mass is. And as this person moves to the left, this log is going to move to the right. So let's figure this out. And I'm going to just draw it again. So this is the 0 point, and then this person is going to make it all the way to the end. But the log has to be moved a little bit. So the log is going to be moving a little bit to the right. So let's figure this out. We know the center of mass is going to stay the same, around 1.83 meters. The mass of this person is 70. And how far he is from the 0 line is just going to be x, how much the log moves. And then when it comes to the log is going to be still 250 kilograms. And it's going to be, it's still directly in the middle, but now it's going to be 1.5 plus this x. So 1.5 plus x. And divide this all by 250 plus 70. So let's try to simplify this. 1.83 times 250 plus 70, which gives us 585, is equal to 70x plus, and let's FOIL this out, 250 times 1.5, 375 plus 250x. I'm going to bring this to the other side, and I'm going to get 210, and then I'm going to combine like terms, 320x, and let's see what x is. 220 divided by 320, we get x as 0.66 meters. Okay, so the log has moved 0.66 meters when he moves all the way to the left. Okay, all right, moving on. All right, let's look at this. Kind of a long problem, but let's see how we do this. A wagon with 2 boxes of gold have total mass of 300 kilograms is cut loose from the horses by an outlaw when the wagon is at rest 50 meters up a 6-degree slope. Looking at the figure, the outlaw plans to have the wagon roll down the slope across the level ground and then fall into the canyon where his competitors wait. But in a tree 40 meters from the canyon edge wait Trevor, mass 75 kilograms, and Max, mass 60 kilograms. They drop vertically into the wagon as it passes beneath them. A, if they require 5 seconds to grab the gold and jump out, will they make it before the wagon goes over the edge? Okay, so a lot going on here. If you want to pause this and try to figure it out on your own, please do that, because I know that was a lot. Okay, so let's see. First of all, let's try to find out how high this wagon was before it got cut loose, and then we can find what the speed is from the bottom here. So if this is 50 meters high and that's 6 degrees, I'm going to use sine to figure that out. So 50 times sine of 6. And I see that the height is equal to 5.23 meters. Now that I know that, I'm going to use conservation of energy to find out how fast the wagon is going at the bottom of the hill. So I'm going to say all the gravitational potential energy turns to all kinetic energy. The mass, which is 300. Gravity, which is 10. The height, which is 5.23, is equal to 1/2 mass, 300, v squared. Mass cancels out. 52.3 times 2 square root. We get 10.23. So we see that the velocity is equal to 10.23 meters per second. So we know when it's at the bottom of the hill, it's going 10.23 meters per second. Now, when it's at the bottom of the hill, these two people fall onto this cart. And what we should know is the momentum is going to be conserved. So we want to find what the momentum is before they fall onto the cart and then after they fall onto the cart. So the cart at the beginning has a mass of 300. It's moving with the speed of 10.23, which we just found. But afterwards, the mass increases 300. These two people jump onto it. So it's going to be plus 75 plus 60. And we want to now find what the new velocity is going to be. So let me put this in. 300 times 10.23. Divide this by 300 plus 75 plus 60. And it's going to give us a velocity of 7.06. So it slows down when these guys land to it. So now they have 40 meters to try to take all this out, and they need 5 seconds. So let's see in 5 seconds, I guess, how far this goes. So we know that speed, the cart's going to go 7.06 meters per second. The distance is going to travel a certain distance, and the time they need is 5 seconds. So let's see how far the distance is before they're able to get rid of all the gold. So I'm just doing 7.06 times 5. And we see that after 35 minutes, they're able to get rid of the gold, and everyone and everything is safe. Okay? Now, the next question. Is the kinetic energy conserved, lost, or gained? So remember, kinetic energy is equal to 1/2 mv squared. When you look at this, you might think, oh, when these people go onto this cart, the mass increased, so the kinetic energy must be more. But then you might have thought, wait, the mass did increase, but the velocity decreased, so maybe it was proportional and it stayed the same. Or you might have thought, oh, mass did increase, velocity decreases, and since it's squared, then that means the speed is more important than the mass, so then that means the kinetic energy was lost. And that would be the case. The kinetic energy is lost because even though mass increases, the velocity decreases, and since velocity is squared, that's more important, and that means the kinetic energy was lost during when those people went onto the cart. Okay, moving on. Let's look at this. A movie stuntman has a mass of 80 kilograms, stands on a window ledge 5 meters above the floor. Grabbing a rope attached to a chandelier, he swings down to grapple with the movie's villain, mass 70 kilograms, who is standing directly on the chandelier. He releases the rope as he reaches the villain. And it's also 5 meters above. Okay. With what speed do the intertwined foes start to slide across the floor? Okay, so they get tangled up after they hit and everything like that. So the first thing we want to do with this person that's flying in, we want to know how fast he's going right before he hits this villain. So again, what we're going to do is energy, conservation of energy. He has all potential energy at the ledge, and then right before he hits it, it turns to all kinetic energy. So we have the mass, which is 80, gravity, which is 10. He's 5 meters high, and it's equal to 1/2 mass is 80, v squared. 80 cancels out. Let's get v, and that's going to be equal 50, to 10 meters per second. So now that we know he's going to hit him at 10 meters per second, let's use momentum, the conservation of momentum, to find out how fast they're doing when they get tangled up with each other. So at the beginning, the guy has a mass of 80, hits him with a velocity of 10 meters per second. And then when they hit him, they're going to intertwine. So they're going to combine their mass, 80 plus 70, and they have a new velocity that they're going to be traveling with. So let's try to figure that out. That's going to be equal to 5.33 meters per second. Lastly, so that's what with what speed do the start to slide across the floor? That's going to be the speed, 5.33 meters per second. The last question is, if the coefficient of kinetic friction of their bodies with the floor is 0.285, how far do they slide? So what we're going to do, we could do a few things. We could do Newton's laws and kinematics for this. But I'm going to use energy. I'm going to use mechanical energy initial plus work non-conserved is equal to mechanical energy final. And this work non-conserved is going to be the work of friction. So at the very beginning, there's kinetic energy. Then there's going to be work of friction. At the end, when they come to a stop, there's just going to be zero energy. So at the beginning, the kinetic energy is 1/2 mass. They have a combined mass, so 80 plus 70. V squared, they're going with the speed of 5.33 squared. Plus the work of friction. So that's going to be the force normal, which is going to be 150 times 10, so 1,500. Times the coefficient of friction, 0.285. That's the force of friction there. So times the distance they travel, which we're looking for, times cosine, and we can see that even though they're sliding to the right, the force is to the left, so this is going to be cosine of 180. This is all equal to 0. So now let's find this distance. 50 times 0.5 times 5.33 squared. Divided by 1500 times 0.25. And we should get a distance of around 4.98. Alright, so that was pretty difficult. I hope you guys are able to follow along. Please look back if you got stuck in anything. And I'm glad you guys watched this. Next chapter is going to be pretty hard with rotational motion. Thanks for watching, everyone.